The magnetic flux in a coil varies with time as shown. Which graph shows how the EMF induced in the coil varies with time? We know that the induced EMF is proportional to the rate of change of the magnetic flux linkage, or just a formula, it's negative n number of coils and delta F over delta T, or in general dF over dt. Its rate of change, it's what? It's just derivative, so we can just consider the derivative of this function. And you can see that there are three regions, 1, 2, 3, and for the first region it's what? It's straight line with increasing it's increasing line, so gradient is positive, or just mass, it's for example y is 10x plus 5 or something like that. And what is derivative? Derivative just plus 10. It's very important that answer is positive constant, because it's increasing line. Gradient is constant, or gradient of the curve is constant, and is positive. And for the third part, for this part, gradient is also constant but negative. It may be, for example, it's just example, negative 10x plus 5, and derivative it's what? Negative constant. And hence for the first and the third parts, EMF, induced EMF values have opposite signs and are constants. So it cannot be B, because it cannot be of the same sign. They cannot be at the same time plus plus or minus minus. So it's A, opposite sign. And it's not C, not D, because for the first and the third parts, derivative it's constant. It's not true. C and D are not true. And for the second part, you can see that magnetic flux is constant, derivative over constant is 0, so there must be 0 in the middle, so it's A. A is correct. And that's all for this question.